Alright, so now we're going to cover the material for Chapter 10, which is our final unit, which is about ocean currents. So first let's talk about what composes ocean water, because that has an important effect on the way it behaves. So the two main elements that compose seawater are sodium and chlorine. And if you remember your high school chemistry class, those two things bond together in some cases to form salt. So that's why ocean water is very salty, in some areas more than others. But the salinity of ocean water is very important in determining how it behaves. So the salinity of ocean water, or the saltiness of the water in other words, is lower near the surface of the water, and it increases with depth. So the deeper we go into the water, the saltier the water gets, the more salinity it has. And that makes sense when you think about gravity. It's, for the most part, gravity is pulling most of the salt down to the surface, whereas a relatively small amount of it is present higher up near the surface. Most of the salt gets trapped very close to the center of the earth because the pull of gravity is very strong. It gets trapped under all the water there. So for as salty as ocean water gets for us near the surface, it's even saltier much further down as we go meters and meters down into the ocean. So deep in the ocean, we have these currents that form a sort of conveyor belt system. We call it the thermohaline conveyor belt system because it's completely reliant upon the balance between temperature and the salt content of the water. And when you just think about what the components of the word mean, that makes sense. So thermo, Greek word for heat, and haline refers to the Greek word for salt. So the balance between temperature and salt content determines how the thermohaline conveyor belt system moves around the deep areas of the ocean surface. So there are two groups of ocean currents. There are surface currents that are driven by wind, and deeper in the ocean, we have deep ocean currents that are driven by the differences in water density. So surface currents near the surface are driven by wind, and deeper in the ocean, those currents are driven by the differences in water density. So the main thing that drives these deep ocean currents is a change in density due to the salt or temperature changes. So again, that's that thermohaline conveyor belt that we just talked about. If the salt content or temperature changes, that's going to encourage a deep ocean current to move. In a similar way to how on the surface, when it comes to air movement, if there's a pressure difference over the surface, that's going to cause air to move. The same thing happens in the ocean, but instead of pressure, it's density, and that density is affected by the salt and the temperature of the water. So surface currents, which are the ones near the surface of the water, they get deflected by the Coriolis force as the Earth rotates, and that causes them to move in circular patterns. Sometimes it almost makes them make a complete U-turn, especially near the poles where that force is the strongest. So the Coriolis effect has a tremendous impact on the flow of water. It has a much weaker impact over air for the most part, but it has a huge impact over how water moves. And this Coriolis effect, as it spins, it creates these large circular ocean currents called gyres. There's a big one in the Pacific. There are others in the Atlantic and the other oceans of the world. There are these huge circular patterns of the water that affect everything from rain patterns. They affect how hurricanes move when it's hurricane season, all sorts of things. So in our country, the United States, the gyre that's out in the Atlantic has a big impact on the climate of the eastern part of our country. So the Gulf Stream is part of that North Atlantic gyre, and what it does is it brings warm, humid air up the coast. If that North Atlantic gyre were to stop flowing, the climate of the East Coast would get a lot more colder than it currently is. So the Gulf Coast has a big impact. The Gulf Stream has a big impact on the climate of the eastern part of our country. It's usually a relatively good one, but sometimes it can create horrible superstorms, like Superstorm Sandy back a couple years ago, where that moist air came up the Atlantic coast. It combined with a hurricane and a blizzard to create this massive, terrible storm. But for the most part, it has a nice calming mediating effect that just brings humid air, warm air up the coast. And another thing about these gyres is that a lot of the plastic waste that gets dumped out into the ocean eventually gets trapped in the middle of these gyres because once it gets funneled in there, it can't really escape because of the way the currents move. So that's why we have these huge islands of just miles and miles of trash out in the middle of a lot of our oceans, because they're stuck in the middle of these gyres by the way currents are moving. Now we'll talk about the elements of the seafloor topography, which you'll need to know a little bit for your exam. And a great diagram of this is found on page 306 of your textbook. I won't show it here because the camera won't be able to pick up all of the intricacies of the map, but you should look at it for sure. It's an excellent map that'll help visualize what I'm about to explain. So there are 5 main elements of the seafloor. First, closest to us on the land surface, is called the continental shelf. So this is the shallow, sloping area very close to the continental margin. So technically, if you're on a beach and wade out into the ocean, you're on the continental shelf. That's the area of the ocean seafloor that is almost attached to the land continent that is above the ocean surface. So it's very shallow relative to the overall depth of the ocean. The second layer is called the continental slope, which is a sort of transition zone between the continental shelf and the true deep areas of the seafloor that are further out into the ocean. Our third layer is called the abyssal plain. Abyssal plains are large, flat areas of the ocean floor that are between 4,000 and 6,000 meters deep from the surface. Next, we have what are called the mid-ocean ridges. The mid-ocean ridges are submarine sort of mountain systems that stretch from pole to pole. They're very, very deep underwater. And lastly, our final layer, very, very deep on the very bottom of the ocean floor, are called deep sea trenches. These are long, narrow valleys on the very bottom of the sea floor, near the center of the earth, right before the mantle layer begins, near the very, very hot part of the Earth's core. And in fact, this area is so close to the Earth's core that sometimes magma from the mantle will leak out into this part of the ocean, and eventually it'll solidify and maybe become land. That's how the state of Hawaii was formed. It was basically magma formed a chain of mountains, and eventually those mountains grew and rose up above the surface of the land. So to recap, from the most shallow to the most deep, it goes from continental shelf to continental slope, then to the abyssal plains, then to the mid-ocean ridges, and finally at the bottom to the deep sea trenches. So I've explained it verbally, but you should look at the map in your textbook on page 306 at the bottom. That shows all of that very well visually. So our final point to close out chapter 10 actually refers back to chapter 5. It's about the El Nino and La Nina events that explain the relationship between the ocean and the atmosphere. So an El Nino event is an event with strong upward convection in the Pacific Ocean. So the air is converging and rising in an area where it normally would not be. The water temperature during an El Nino event is well above average normal conditions, and there's an area of low pressure in the eastern Pacific near South America, and an area of high pressure in the western Pacific near, say, Australia and Indonesia, places like that. So what that does is it creates a drought in the areas near the high pressure system, and it causes a ton of rain in the eastern Pacific. That's an El Nino event. The opposite of that is called a La Nina event, which is a strong reversal of El Nino conditions. So it's sort of course correcting. During a La Nina event, the water temperature in the eastern Pacific is well below average. So there's a high pressure system in the eastern Pacific and a low pressure system in the western Pacific. So what that does is it brings a lot of rain to Australia and Indonesia because of that pressure gradient difference, because it's moving from high pressure to low pressure. And one of the things that's really strange about this El Nino and La Nina phenomenon is that it doesn't really seem to occur at any regular pattern. Sometimes it goes years before you have an El Nino event or La Nina event. Other times they bounce quickly back and forth every other couple of years. There doesn't seem to be really any rhyme or reason as to when or why these things happen, and it's difficult to detect when one is happening until we're about a year or two into it already happening. It's a very erratic and strange climate pattern that we're still trying to learn a lot about, because it really baffles us in a lot of ways. And now my final point, on your exam, you're going to have to be able to look at this graph and identify which is an El Nino event and which is a La Nina event. So this is on page 155 of your textbook, back in chapter 5. And you'll notice that this is a El Nino event because the red denotes that the water temperature in the Pacific right here is much higher than it would normally be. Whereas in the La Nina event, here on the right, notice that the water temperature is marked in blue because it's much colder there in the eastern Pacific than it would normally be. So that's how you can tell the two apart. This is an El Nino event. This is a La Nina event. This is on page 155 of your textbook. So make sure that you know this graph for your exam, because I think we use a very similar, if not the same picture as this one. All right, so that wraps up all the exam material that you're going to need to know for your second exam. I hope watching these videos was helpful to you. You can always email me or Dr. Trepanier any questions you may have, and I'm going to continue to post some additional helpful videos I might find onto the Exam 2 review page on our Class Moodle site. So thanks for watching. You be safe out there.